Hello and Assalamu alaikum. In this tutorial, I'm going to talk about regression analysis. So let's see what is the definition of regression. Regression is a statistical technique that determines the linear relationship between multiple variables. So primarily, regression can be used to predict the relationship between variables. Whenever we have to see the causes and effects of variable, we apply regression. So this technique can also be called as a hypothesis testing approach. In a quantitative research, we normally generate hypotheses. So by using regression analysis, we can test the hypothesis. With the help of the results, we can test the hypothesis, that whether the hypothesis is supported in our context or it is rejected. So before applying regression, you have to first categorize which variables are dependent and which are independent, because it is one of the dependence technique. So mathematically, let's see one of the regression equation. It is just the general equation. Here you can see y represents, at the left side, y represents dependent variable and x represents independent variable. Beta naught is the constant, it is the intercept, and beta 1, here you can see beta 1, this is the slope parameter. With the help of beta 1 value, beta 1 coefficient, you will be able to predict the direction, that what is the impact of x on y, whether the impact is positive, what is the direction, whether the direction is positive or negative. You can also predict the change in y with respect to change in x. And in the last, you can see there is a symbol mu. This symbol represents the error term. So in order to estimate the equation, we can apply regression analysis. So let's see how we can apply regression using Spss. But before that, suppose an example. So this is the model, this is the conceptual model I want to estimate. Here I have 4 variables, 3 are independent. At the left side, social need, social influence and convenience, and the right side, purchase intention is my dependent variable. So the objective of my research is to see whether these variables, social need, social influence, convenience, have an effect on purchase intention, and how much there is a change in purchase intention when social need changes, and so as social influence and convenience. So here, in order to fulfill the objective, in order to fulfill my research objective, I'm going to apply regression analysis. But before that, let's see some assumptions. So you have to first see the assumption of regression. If the assumptions are fulfilling, then only we can apply regression analysis. The first assumption is that the data should be normally distributed, the relationship between the variables should be linear, and the dependent variables should be scaled. So it means whenever you are applying regression analysis, you cannot use dependent variable, any categorical variable as dependent. For example, gender. So you cannot make gender as dependent variable when you are applying linear regression test. So now we are ready to apply and we are ready to estimate this conceptual model. So if you are ready, let's get started. So this is the data file I'm going to use. Here I have, as it is mentioned in the conceptual framework, I have 4 variables: social need, social influence, convenience, purchase intention. So based on the validity and accuracy, I have constructed the variable and make them in one composite index. Like this is social need. So these are some computed variables. So after applying factor analysis, I computed variable social need, social influence, convenience, and purchase intention. And now I am going to apply regression analysis on these 4 variables. So let's start the process. In order to apply regression, you have to go to Analyze, and here you can see regression, and as it is mentioned, we are going to apply linear regression. So I don't want to use these questions, so here are some variable, the computed variable. Remember, whenever you are applying regression analysis, you have to first compute the variable which you, like before applying regression, you have to apply exploratory factor analysis, and in exploratory factor analysis you have to compute variable based on the accuracy, right? And you only compute those variable which have high correlation, right? So here in regression, you are not going to use single questions, you are going to use the computed variables. So in this case, the dependent variable is purchase intention, so I am going to move this variable into the dependent box. And these 3 variables, social need, social influence, and convenience, these 3 are independent variable, so move them into independent variable box. Remember one thing here, that dependent variables should be scale. Right, I am fulfilling all the assumption. The data is normally distributed because I have, before applying regression, my data is clean, right? I have removed outliers, there is no missing values, so I am assuming that the data is normally distributed. The data is also, the variable is also linear. And secondly, the last assumption is that the dependent variable should be scale. So here you can see, as here purchase intention, the measure is a scale. This variable is a scale. It is not a dichotomous variable, it is not a binary variable. For example, if the dependent variable is gender, so you will not be able to apply linear regression. For that, you have to go for some other analysis like logistic regression or some other, right? So now I'm going to check only one option. Just go to statistics, and there is one option, collinearity diagnostic. Just check this option, press continue and press OK, because I'm ready to set. Let's press OK. Okay, this is the output. Okay, this is the output. Now you can see there are different tables. Model summary, here you have R square, adjusted R square. In this table you have F-stat sick value, and this is the coefficient table. So you have to read each table one by one, and based on some values you have to draw some conclusion. Okay, for interpretation, you have to first see the R square value. Now, what is R square? R square tells us what percent of the variability in the dependent variable is accounted by the independent variable. In simple words, we can say that how much independent variables are predicting our dependent variable. So this value tells us the variability, the percentage, that how much it is predicting. For example, if the value of R square is 0.40, it means 40% independent variables are predicting dependent variable. The second thing is F-stats. Here we only see the probability, right? So we have to see, as we already know, the level, the significance level, which is 0.05 or lesser. So if the probability, so let's see what is F-stats first. It depicts the overall combined effect of the model. It depicts whether the model is fit or not. So when the probability of F-statistics is lesser than 0.05, it means it is significant and the overall model is fit. Now the third thing is beta coefficient, the slope values. It tells us the change in dependent variable with respect to change in independent variable, and it also tells us the direction that one variable has what type of effect, positive or negative or so on. So now based on these values we are going to interpret the result. Okay, these are the output. So one by one I'm going to interpret the tables. The first table is just the description. Here it is mentioned that which method you have used. So we have used enter method, so we don't have to use it in our decision making process. In the second table, model summary. So here we have to see two values here, r square and adjusted r square, right? Both the value depict the variation in the dependent variable with respect to independent variable. So we can report both of the values. Here you can see r square. So it means 40.9% are independent variables are explaining dependent variables. So for example, social needs, social influence, and convenience are predicting purchase intention 40.9%, right? Similarly, adjusted r square, these are some adjusted values. So here the meaning of both the values are same, right? So we can report both of them. In the second table, you have to take decision based on the F statistics and its significance value. So here, if the significance level is less than 0.05, we will conclude that the model, the overall conceptual model is fit. We can proceed further. If the value is not it is not meeting the criteria, that is, if it is greater than 0.05, then we will have to see the model. We have to do some amendments in the model. We cannot proceed and we cannot draw the conclusion based on these results, right? But if the value is okay, is meeting the criteria, that's fine, we can proceed. So here in this case, F statistics significant value is lesser than 0.05. Hence, we can conclude that the overall model is fit. It is significant. Now in the third table, the table is coefficient. Here you can see there are different columns. Unstandardized beta, coefficient standard error, standardized coefficient beta, t-stat, sig value, and collinearity statistics. So for now we are just not going to discuss collinearity diagnostic. We are not going to discuss these two tables just for now. Let's discuss beta and t value and sig value. So as you already know, sig value, this is the significance level. It tells the significance level of the relationship, whether the two relationship is significant or insignificant. And so as t value depicts the same, it is also telling us the significance level of the relationship. Whereas beta tells us the change, it is the slope, right? So here you can see unstandardized and standardized beta. So you can report any of them. Unstandardized beta and standardized beta difference is that standardized beta is the value which is divided by the error, the standard error, right? But the relationship is same. The values can be different, but the relationship is same, right? So I'm going to use this unstandardized coefficient because here there is a value of constant, so therefore I'm just using unstandardized beta here. So one thing you already know that when the value is less than 0.05, it is said to be significant. When it is greater than 0.05, it is insignificant, right? Now let's see. Beta tells the change, the magnitude, change in magnitude. So here how we can interpret the result. So let's see. by using these results, by using these values, how I am interpreting the results. So I'm going to consider unstandardized beta and the sig value. I'm not using t-stats because t-stat and sig value is same. Both are telling us the significance level. So you can use t-stats and you can use significance level as you want. And unstandardized and standardized beta's difference I already explained. So there is no change in the relationship, but the values, you can see the change in the values, right? Because here in the standardized coefficient we are dividing unstandardized beta with the standard error. So therefore the values are, you can see the change in the values. So let's interpret. So the first relationship is the relationship between social need and purchase intention. So the first relationship is social need and purchase intention. So let's see what is the result, what a result is illustrating. Here we can see that social need has a positive and significant impact on purchase intention. So why I'm saying positive and significant? Because there is no negative sign, so we assume that there is a positive impact, and significance is because the significance level is lesser than 0.05, and we know that whenever we have significance level less than 0.05 we conclude it as significant. So here we have positive and significant impact of social need on purchase intention. We can also interpret in the like another way. When social need increases by 1 unit, purchase intention, when social need increases by 1 unit, purchase intention increases by 0.276 unit. So the relationship is positive, that is why it is increasing, and these values, they depict change. These magnitudes are showing change in dependent variable with respect to independent variable, right? So we can interpret the other variable in same manner. Social influence has a positive and significant impact on purchase intention, and convenience also has positive and insignificant impact on purchase intention. So based on the values, if we can see the values, convenience 0.334, they are greater than, like among others this value is greater. So we can see that convenience has the highest impact on purchase intention. Now as far as constant is concerned, statistically the definition of constant is when all the variables are 0, when the coefficient of all the variables are 0, then the dependent variable is equal to constant. So when, if we assume that social need, social influence and convenience has no coefficient, here it is 0, then purchase intention is equal to 1.174. This is the interpretation of constant. So this is the result, and based on this we can also test the hypothesis as I mentioned earlier. So how we can test the hypothesis? For example, so let's see, this is my conceptual model, and here I have hypothesized the relationship of the variables. So the hypothesis 1 is social need has a positive impact on purchase intention, and after reviewing several papers on this particular topic, then afterward I developed these hypotheses. So now I have to see that whether these hypotheses that I generated earlier, it is supported or not supported, right? So now I have to see the result of regression, and based on that regression I will conclude that whether the hypothesis I generated is supporting or not. So the first hypothesis was about social need, and it was hypothesized as social need has a positive impact on purchase intention. So as you can see, we are getting the same result. Social need has a positive impact on purchase intention. So now in this case, I will conclude that my hypothesis is supported. But the second hypothesis that I hypothesized was social influence has a negative impact on purchase intention. But in this case, there is a positive impact. So I will conclude that the hypothesis is rejected because the result is contrary. It is just opposite. And convenience hypothesis was also that convenience has a positive impact on purchase intention, and it is also positive. It means this hypothesis is also supported. So in this manner you can test the hypothesis. But how we are so sure that the results we are interpreting is accurate? It is not biased. There are some problems in regression models. If those problems exist in our model, it creates distortion. It creates some distortion. It gives biased and inaccurate result. And the problem, there are various problems, but here we are going to discuss only one problem, and that problem is multicollinearity. So this is an illness of regression. If it exists in the model, if it exists in the regression model, there is some distortion. It creates distortion and it gives inaccurate, false results. So what is multicollinearity? Multicollinearity occurs when there is a relationship between independent variables. When our independent variables are not independent, they are correlated with each other. Like if we are saying independent, so it must be independent. It must not be correlated with other. If there is any correlation, it creates some problem, and that problem is known as multicollinearity. So if the relationship between independent variable is high, it causes problem, and especially it distorts the model results, and it will give us false and biased results. So it is very important to detect and remove multicollinearity from the model. So how we can detect the multicollinearity problem in the model? We can detect multicollinearity with the help of variance inflation factor, VIF, which is an indicator of multicollinearity. If the value of VIF is equal and lesser than 10, it will be concluded that there is no multicollinearity, there is no severe multicollinearity. If the value is greater than 10, then there is some problem and we have to fix it out. We have to fix the problem first. So let's see, by just seeing the value of VIF, let's see whether the model we have just estimated has multicollinearity issue or not. So as you can see at the right side, collinearity statistics, under the heading of collinearity statistics, there is one column named as VIF. So remember, the threshold is that the VIF value should be less than 10. So here the values are 1. So they are far lesser than 10. So we can conclude that there is no multicollinearity in the model, and the estimated results are accurate and unbiased. But if there is any issue of multicollinearity in the model, we first have to detect the variables, those independent variables that are correlated with each other, and after detecting it, we have to remove it from the model. Secondly, by applying factor analysis, by applying the method of principal component analysis, we can also reduce multicollinearity from the model. Thank you.